I am very happy to welcome you all optical communication lecture series under the unit 4 titled optical receiver measurements and coupling. Let us discuss preamplifier working process in this presentation. This disclaimer is applicable to all the participants or listeners by online platform. After watching this video, students may be aware about to be analyze the various operations of preamplifiers. Preamplifier. What's preamplifier? What's the necessity of this? So sensitivity and bandwidth of receivers are affected by noise sources in the front end. In order to improve the sensitivity of our fiber optic communication system, we are going for preamplifier. Preamplifier should give maximum receiver sensitivity with the desired bandwidth. So preamplifiers also used in optical fiber communication receivers. It classified major three types. First one is low impedance preamplifier. Second one is high impedance preamplifier. Third one is transimpedance preamplifier system. Now let us look into low impedance preamplifier. It's a very simplest one, but we could not design optimum design. Photodiode operates in low impedance amplifier approximately 50 ohm. Bias resistor or load resistors used to match amplifier impedance by suppressing standing waves or give uniform frequency response. RB with amplifier capacitance gives bandwidth equal to or greater than the signal bandwidth. Low impedance amplifier can operate over wide bandwidth, give low resistivity as a small voltage develop across the amplifier input and RB. Hence used only for short distance applications where sensitivity is not of the concern. High impedance preamplifier. Noise reduced by reducing the input capacitance by selecting following things. First one is low capacitance, high frequency devices. Second one is detector of low dark current. Third one is bias resistor of minimum thermal noise. Thermal noise can be reduced by high impedance amplifier with large photodetector RP. Hence, high impedance amplifier is used as FET and bipolar junction transistors, but causes large RC time constant with low front-end bandwidth. Signal gets integrated. Equalization techniques is required. Integrator and differentiator is core function of high impedance amplifier design. Gives low noise but low dynamic range of signal. Then transimpedance amplifier. Although a high impedance amplifier design produces lowest noise amplifier, it has two limitations. For broadband applications, equalization is required. It has high dynamic range. This is the structure of high impedance preamplifier design by using bipolar transistor amplifier. It consists the bipolar. This is our bias voltage divider bias. It consists base emitter collector things. Main amplifier is connected over here. Followed by here we have equalizer. When bias resistance R1 and R2, this bias resistance R1 and R2 far greater than RA. This is our design process of high impedance amplifier preamplifier using bipolar junction transistor. For low noise level design, R1 and R2 chosen as to be greater than R input resistance. Spectral density of input noise current results from the short noise of base current represented as S1. Photodetector bias resistance RB is greater than amplifier resistance. This is the design equations for that. Next, let us look into high impedance preamplifier design using field effect transistors. Again, here we have FET connected over here. It consists gate, drain, sources, followed by main amplifier equalizer. The rest of the things are same to as our previous things. This is the design process of high impedance FET. Amplifier input resistance is very large. The input current noise spectral density S1 is represented over here. Thermal noise of at the equalizer output also given in this equation. This is the design process of transimpedance amplifier. It consists photodetector, resistance RB. Here in addition, here we use feedback resistance. This is a transimpedance amplifier equalizer output and transimpedance amplifier transfer function. Benefits of transimpedance amplifier: wider dynamic range compared with high impedance amplifier design. No equalization is required. Output resistance is small. so that amplifier is less susceptible to pick up noise. Crosstalk and EMI is minimum. Thank you.